Hey everybody, welcome back to Mr. Rowley's Virtual Music Classroom. This lesson will be the fourth lesson in the music theory series, and it's going to be regarding pitch. Remember back to Elements of Music in lesson 1, that pitch is the relative highness and lowness of sound. We have notes that we place on a staff that tell us what pitch to play or sing when reading music. Today's lesson is going to center mostly around intervals, and specifically simple intervals, all the intervals within an octave. An interval is basically just the space between two pitches. Before we get to intervals, however, we need to talk about enharmonics. Enharmonics are two pitches that look different in music, but they sound the same. And let's remember something. Within an octave, there are actually 12 pitches. From C to C. If you were to put your finger on the middle C and then go up every single note to the next C, there's going to be 12 pitches. Some of those pitches on the paper will look differently but sound the same, and that's what enharmonics are. The other thing that I want to let you know is throughout this lesson, I'm going to be using middle C as our bass, and not our bass note, but our bass line pitch. And from that, I will talk about the intervals between middle C and the next pitch. This can be done between any two pitches though, which will be in a future lesson, and a lesson we'll talk about compound intervals, which are larger than the octave. Today's lesson though is just simple intervals within the octave. And here's some examples of enharmonics. As we look at some examples of enharmonics, I'll be using not only the printed notes, but also using the piano and the guitar to show the examples of what they look like on the instruments and sound like. Obviously, they're enharmonics, so they sound the same, but I want you to see that they look differently, even though they sound the same. C sharp and D flat are enharmonically the same pitch. C sharp and D flat are enharmonically the same pitch. D sharp and E flat are enharmonically the same pitch. D sharp and E flat are enharmonically the same pitch. E and F flat are enharmonically the same pitch. E and F flat are enharmonically the same pitch. E sharp and F are enharmonically the same pitch. E sharp and F are the same pitch. F sharp and G flat are enharmonically the same pitch. F sharp and G flat are enharmonically the same pitch. G sharp and A flat are enharmonically the same pitch. G sharp and A flat are enharmonically the same pitch. A sharp and B flat are enharmonically the same pitch. A sharp and B flat are enharmonically the same pitch. And finally, B and C flat are enharmonically the same pitch. And finally, B and C flat are enharmonically the same pitch. Now that we have a pretty good understanding of what enharmonics are, now let's take a look at pitch intervals within the octave from middle C to the octave above C. As we look at the intervals, and again, these are simple intervals because they're all the intervals that are within an octave. But as we begin looking at them, we need to understand that all intervals are made up of half steps and whole steps. Sometimes those are referred to in some books and by some professors in colleges as semitones for half steps and tones for whole steps. I'll give an example of these looking at the piano so they're easy to understand. As we look at the examples of all the different intervals, the first interval, well actually it's the second interval we see, is the minor second. And the minor second is a half step. A major second is a whole step. And all the intervals after that are a combination of half steps and whole steps. We will talk more about that when we get to talking about scales, which will be in the next lesson, because scales are made up of patterns of half steps and whole steps. And then we'll also talk about them when we talk about chords, our first lesson on chords, which will actually be the lesson number 6, right after the scales. So I'm going to give you a little bit of demonstration on the piano of half steps and whole steps, and then we'll get right into intervals that are in the octave. A half step on the piano is from one note to the next key next to it. So white, black, black, white, white, black, black, white, white, white. There's no black key, but so this is still a half step. So half step, half step, half step, half step. Now, easy math, a whole step is skipping one key. So if we skip a black key to the next white key, that's a whole step. That's a whole step. That's a whole step. From here, that's not a whole step, that's a half step. That's a whole step. That's a whole step. So half steps, whole steps. If we have a bigger interval, which you'll learn about, let's use the perfect fifth as an example. So that's a whole step, half step, whole step. So that's 3.5 steps. 1, 2, a half, 3. 3.5 steps make up a perfect fifth. So that gives you an idea about half steps and whole steps, also known as semitones and tones, or semitones and whole tones. The half steps are the distance between frets. These are these metal things that go up and down here. Push the finger down on the 3rd fret here, 2nd string from the top. That's a C, that's middle C, same as I was using on the piano. Next fret up, half step. Next fret up, half step. Now on the guitar, the next string up and from the 5th fret is the same pitch. So half step, half step, half step. Now the whole steps, just like before, we're going to skip a fret. Whole step, whole step, whole step, whole step. Okay? Now, Let's do that same interval that we did before from C to G. Okay, there's the fifth. Half step, half step, half step, half step, half step, half step, half step. Whole step, whole step, whole step, half step. 3.5 steps make up the interval of the perfect fifth, okay? Both instruments, the piano and the guitar, are pretty easy because you can see the keys and you can see the frets. And that's how we understand half steps and whole steps. And again, like I said after the piano, semitones or whole tones. Another word for it, we normally use half steps and whole steps though. As you go through listening and watching the interval examples, you're going to see them played twice, named, played on the piano, played on the guitar, and then played together. There's a little bit of ear training here. That's the reason I've repeated them. I've repeated them so your ears get to learn how they sound, but also to see what they look like being played on a piano and what they look like being played on a guitar, as well as what they look like in the written music. Ear training is something that starts at this level. Listening to the notes and how they relate to each other is a really important skill for musicians to have. And it's especially important when you're conducting or composing. So as you look at them, keep in mind the reason you're hearing things 3 times is for the reason of ear training. Come back and listen to them often. At the end of this video, I'll give some apps and programs that may help you do more ear training in dealing with intervals, because they'll help you in the future as a musician. As you look at the intervals that are coming up next, you will see some that I wrote above in the music, like very rare, or very, very rare, and why, and things like that. Those are because those are intervals that are normally not used in music. We do see them. Sometimes we see them in jazz, and sometimes we see them in very contemporary music. And there always usually is a reason that the composer or arranger used a spelling that's of 2 notes or within a chord that's not common. But there's a function to that. So that's why we do see those very uncommon intervals. I wanted to show all of them to you, and again, here they are. A perfect prime interval, C and C. The interval of a perfect prime an augmented prime, which is very rare because it's the same as the next interval. The interval of an augmented prime, which is very rare because it's the same as the next interval. A minor second, when we're seeing the second pitch as D flat. A minor second, a major second, a major second, an augmented second, An augmented second. A minor third, which sounds the same as an augmented second. A minor third, which sounds just like the augmented second. A major third. A major third. An augmented third, because it sounds the same as the next interval. An augmented third, very, very rare because it's the same as the next interval. A perfect fourth. A perfect fourth, again, sounds just like the last one. An augmented fourth, also known as a tritone. An augmented fourth, also known as the tritone. A diminished fifth, which is also a tritone. A diminished fifth, also the tritone. A perfect fifth. A perfect fifth. An augmented fifth, because again, it sounds like the next interval. An augmented fifth, again, very rare because it's the same as the next one. A minor sixth. A minor sixth. A major sixth. A major sixth. An augmented sixth, again very rare because it's the same as the next interval. An augmented sixth, again very rare because it's the same as the next one. A minor seventh. A minor seventh, same as the augmented sixth. Major seventh. A major seventh. An augmented seventh could happen, very rare, who knows why, but it's possible. An augmented seventh, again very rare because why? A perfect octave, the same as the augmented seventh, which is why would you ever write an augmented seventh? Why the augmented seventh? Because it's the same as the octave. And finally, an augmented octave. And again, you would probably never see this, but it is possible. And the augmented octave. Again, why? Okay, Now you've had the opportunity to see every possible interval that we can see within an octave. And actually the last one, just a half step higher than the octave. There's a lot of reasons that some of those intervals are not necessarily used and they seem kind of weird. And that's okay, but they theoretically do exist. For instance, a prime and then a augmented prime doesn't make a lot of sense, but they can exist. And there's theoretical reasons for that. And it's based on scales and how music is structured. And as you get better at writing music, and not just melodies, but writing the harmonies in music, which is complex and can be difficult, that's when those weird intervals could come into play. But most of the music that you're going to be learning about, and the theory that you're going to be attempting, is going to be with the more common and less abstract intervals that you see. But I wanted to show them all to you. My guess is this is something that's quite new for most of you. Learning about intervals can be a little bit difficult, but it's the first building blocks of learning why scales work the way they do. And later on, when we start adding chords to music, how chords work. So just be aware of that. You did get one little glimpse into chords because every time I showed you an interval, I showed the two notes apart from each other, and then I showed them being played together. Playing those intervals together is, in a sense, playing a chord, because the actual definition of a chord is any two notes played simultaneously. I hope this lesson expanded your mind a bit on what the building blocks of music. Intervals can be a little bit difficult to understand, but now that you had some practice with the simple intervals, come back to it, especially when we get into the next lessons dealing with scales and chords. Your understanding of intervals will become very important. I hope you learned something. I hope you enjoyed it, and I hope you'll come back for the next lesson. Thanks. Thanks for following my lessons and partaking in what I have to offer here. Please remember to like, share, and subscribe. And again, thank you.